That moment when the most powerful telescope humanity has ever built looks so deep into the cosmos that it sees things that shouldn't exist. That's the moment we're in right now. The James Webb Space Telescope isn't just taking pictures. It's revealing a universe so fundamentally shocking, it forces cosmologists to question everything we thought we knew about time, gravity, and even reality itself. We're about to show you the impossible galaxies and ancient black holes that are keeping astronomers awake at night. If discovery is your thing, subscribe to Stellify Science and turn on notifications so you never miss what the universe reveals next. The discoveries I'm about to share aren't just surprising, they're impossible according to our best models of physics. They are breaking the fundamental rules that govern cosmic evolution. We're talking about fully formed megagalaxies existing in a time when the universe was barely old enough to form its first tiny stars. That paradox is the first of several mind-bending revelations we're diving into. Before we unpack this impossible science, let's quickly frame the instrument itself. The James Webb Space Telescope, or JWST, is not just another space eye. It's a $10 billion marvel, 2 decades in the making, now orbiting 1 million miles from Earth. It collects light that has been traveling for billions of years, giving us a literal look back in time. The further back it looks, the closer it gets to the Big Bang, the universe's infancy. Now, hold that image of the early universe in your mind. According to our established model of cosmology, often called lambda CDM, the universe right after the Big Bang went through a dark ages. This was a cold, dark expanse filled only with simple hydrogen and helium gas, slowly clumping together under gravity. This period should have been populated only by small, primitive protogalaxies, just beginning to ignite their first stars. We should be seeing cosmic toddlers. In just a moment, we'll show you what Webb actually found. But first, let's nail the expected timeline. The first stars weren't supposed to ignite until at least 400 million years after the Big Bang. And real, structured galaxies weren't supposed to form until significantly later. The cosmos should be simple, dark, and utterly primitive. This is the foundational expectation the entire scientific community agreed upon. So, what happens when Webb looks back into that era, just a few 100 million years after the Big Bang? It is not finding simple cosmic toddlers. Instead, it is finding fully grown elephants. Webb is discovering massive, complex, and astonishingly mature galaxies that are so large, so rich in stars, and so structurally sophisticated that they should not exist yet. We're talking about galaxies with billions of stars and mature structures. The kind of structures that, based on our models, should have taken billions more years to form. This is the first earth-shattering revelation. The early universe is absolutely packed with these impossible giants. According to the math, the timescale simply does not add up. The universe at 300 million years old, where Webb is seeing these giants, simply hasn't had enough time to accumulate the gas, form the stars, and assemble the structures required for such massive galaxies. It's like finding a 50-year-old tree in a forest that was planted yesterday. Let's zero in on one example that has astronomers reeling. A galaxy designated JWST Z13-0.
And yet
This galaxy appears to have formed when the universe was only 325 million years old. But here is the kicker. Its sheer mass and level of maturity would have required more time to form than the universe had actually existed at that point. The calculation breaks down entirely. It's a clear signal that a core piece of our cosmic evolution model is fundamentally wrong. And it's not an anomaly. Webb has found dozens of these impossible galaxies. The early universe isn't sparsely populated. It's crowded with these cosmic behemoths. This forces us to confront an unbelievable possibility. Either the universe is much older than 13.8 billion years, or cosmic evolution happened at a rate that is accelerated beyond anything we conceived. In a moment, we'll explore the implication that the laws of physics themselves might have been different back then. But the impossible galaxies are just the first shockwave. The second is the discovery of ancient, fully formed quasars. Quasars are the blazing cores of galaxies, powered by supermassive black holes that are actively feeding. They are the brightest single objects in the universe. The problem, once again, is the timeline. Supermassive black holes are supposed to be the end result of a long evolutionary process. Smaller black holes forming from dead stars, then merging and growing over billions of years. This process is slow and requires enormous time. Yet, Webb is finding fully formed supermassive black holes when the universe was less than 1 billion years old. Some are appearing when the cosmos was only 400 million years old. These are not tiny seeds. They are actively feeding supermonsters, surrounded by glowing accretion disks, illuminating their surroundings across millions of light years. They have no business existing yet. Consider the quasar, J1120+0641. This black hole is over 800 million times the mass of our Sun, and it existed when the universe was only 7 million years old. If the universe were an 80-year-old human, this black hole would be a fully grown adult present when humanity was only 8 years old. The formation models for black holes, how they grow from stellar remnants to supermassive objects, require too much time. So, how did these black holes grow so fast? Did they have a secret, accelerated path to supersize? That's the key question. We'll explore the radical, heavy seed theory in a moment. But first, let's consider the most unsettling observation Webb has made, one that cuts to the very structure of space itself. Webb's precise measurements of the redshift of distant galaxies, which tells us how fast space is expanding, are revealing inconsistencies that simply don't match our models. Some regions of space appear to be expanding faster than others. This is hinting that the fabric of space-time might not be the smooth, uniform thing we have always assumed. This inconsistency points to a terrifying possibility. Our universe might not be the smoothly expanding balloon we were taught. It suggests that space-time itself might have a structure we never suspected, and that our entire framework for understanding the cosmos, which relies on a uniform expansion, might need to be rebuilt from the ground up. This brings us back to the overarching problem: the existence of massive, mature structures in a universe that is supposedly an infant. Let's dig deeper into the impossibly mature problem with the example of a galaxy cluster designated SMACS JWST. This cluster, one of Webb's first full-color images, contains dozens of massive galaxies that appear to have formed simultaneously in the early universe. Galaxy clusters are the ultimate test of cosmic time. They are supposed to be the result of billions of years of gravitational evolution, with individual galaxies slowly coming together. Finding a massive, complex cluster when the universe was in its infancy is like finding a perfectly orchestrated symphony being performed by musicians who haven't been born yet. The sheer gravitational binding energy of SMACS J0723 suggests it contains dark matter structures that would have taken longer to form than the cluster's measured age. The physics simply doesn't add up. This observation forces cosmologists to question whether our fundamental understanding of how dark matter behaves on cosmic scales is completely wrong. Maybe dark matter was already clumped and ready to go much earlier than our current simulations allow. Now, let's talk about speed. Webb has been measuring the stellar mass density of these early galaxies. Essentially, how much star-forming material they contain. The results are breaking every current model. These ancient galaxies contain stellar masses that are orders of magnitude higher than what should be possible given the limited time available for star formation. They are converting gas into stars at rates that would require processes we've never observed in the modern universe. It is as if these early cosmic structures had access to an accelerated stellar evolution mechanism that defies the known laws of astrophysics. Consider a galaxy web designated as CERS 93316. This object appears to contain over 100 billion solar masses worth of stars, and it formed when the universe was only 235 million years old. To put that in perspective, our Milky Way galaxy, which has been forming stars for over 13 billion years, contains roughly the same stellar mass. How is it possible for a galaxy to accomplish in 235 million years what took our galaxy 13 billion years to achieve? This forces a terrible choice. Either our understanding of star formation is fundamentally flawed, or there were physical processes operating in the early universe that no longer exist today. Perhaps gravity behaved differently, or maybe the initial conditions were already structured in a way that we cannot currently account for. The scientific surprises keep coming as Webb digs into the chemical makeup of these cosmic giants. The telescope is detecting spectral signatures of heavy elements that shouldn't exist yet. Remember, the universe started with only hydrogen, helium, and a tiny trace of lithium. All the heavier elements, the oxygen, carbon, iron, and gold that make up life and planets, had to be forged inside the cores of massive stars and then dispersed through supernova explosions. This process of cosmic chemical evolution is supposed to take billions of years. It's the cycle of stellar life and death that enriches the universe. The first generation of stars had to live and die before the second generation could form, with the complex chemistry we see today. But Webb is detecting mature chemical signatures in galaxies that formed when the universe was barely old enough for even the first generation of stars to have completed their life cycles. One galaxy Webb observed shows clear spectral lines for oxygen, neon, and even iron when the universe was only 400 million years old. Based on our current supernova rates, it should have taken at least 500 million years just to produce detectable amounts of these elements, even under the most optimistic scenarios. This is forcing scientists to conclude that stellar evolution must have happened faster, or supernovae must have been more frequent and violent in the early universe. What's particularly unsettling is that the ratios of these elements suggest sophisticated cycles of stellar birth and death that should have taken multiple generations of stars to establish. It's like finding a complex ecosystem in a newly formed lake, complete with intricate food webs that should have taken millions of years to evolve. Let's turn now to the luminosity problem. Webb detected a galaxy designated GNZ 11 that appears to be shining with the brightness of 25 billion suns, when the universe was only 420 million years old. The energy output from this single galaxy rivals some of the brightest quasars we know of today. The mechanisms to produce this kind of luminosity shouldn't have existed yet. This extreme light output suggests either massive star formation rates that defy physics, or incredibly active supermassive black holes that simply couldn't have formed in the time available. Either explanation breaks our understanding of how cosmic objects generate energy. Specifically, the spectrum of GNZ 11 shows that it's actively forming stars at a rate of over 20 solar masses per year. That's a pace 20 times faster than our entire Milky Way galaxy does today, and it's sustaining this incredible rate of stellar birth when the universe was barely old enough to form its first stars. This is another piece of evidence for an accelerated early universe. Further complicating the picture, Webb has been detecting what scientists are calling red nuggets in the early universe. These are incredibly dense, compact galaxies containing enormous amounts of mass squeezed into relatively small volumes. They are so dense that their gravitational fields are warping the very light trying to escape them. One red nugget that Webb discovered appears to contain the mass of 100 billion stars, packed into a region smaller than our local group of galaxies. The gravitational forces required to hold this much matter in such a compact configuration should create tidal effects that would tear apart normal stellar structures. Yet, they exist and appear to be stable. This suggests a powerful, unknown mechanism for rapidly creating highly concentrated matter. Webb's measurements of the rotation curves of some of these early galaxies, which tell us how matter is distributed, are adding another layer to the dark matter mystery. These ancient galaxies are rotating in ways that suggest they contain dark matter distributions that are fundamentally different from what we see in contemporary galaxies. The dark matter appears to be more centrally concentrated, more tightly bound, and more massive, relative to the normal matter than our theories predict should be possible. If our understanding of how dark matter behaves is fundamentally wrong, if it's not the simple, inert halo we thought, then our entire picture of cosmic structure, formation needs to be completely rewritten. This possibility is perhaps the most fundamental threat to our current model of cosmology. But the most shocking revelation of all is what Webb is revealing about the cosmic web itself. The cosmic web is the universe's largest structure, a vast, sponge-like network of dark matter filaments that connect galaxies across billions of light years. This web is supposed to form gradually as gravity pulls matter together over cosmic timescales. However, Webb is detecting signatures of this mature cosmic web structure in the early universe, when it should still be in the very beginning stages of formation. The telescope is seeing correlations between the positions and orientations of early galaxies that suggest they're already embedded in a mature web structure when the universe was less than 1 billion years old. This is revolutionary because it implies that the large-scale structure of the universe might have formed much earlier and much faster than we ever imagined possible. The cosmic web, which we thought took billions of years to develop, might have been essentially complete when the universe was still a cosmic infant. This suggests a powerful initial seeding of structure, possibly through mechanisms we have yet to discover. Now, let's turn to an implication that challenges the very nature of time and causality. The cumulative data points toward phenomena that hint at a truly bizarre universe. Webb is starting to detect what can only be described as cosmic coordination on scales that should be impossible. The telescope has been observing correlations between galaxy formations that are separated by distances so vast that light hasn't had time to travel between them since the Big Bang. We're talking about galaxies that appear to be synchronized in their evolution, despite being causally disconnected from each other. The implications are mind-bending. Either information can travel faster than light, which breaks relativity, or there are hidden, pre-existing connections in the fabric of space-time that we've never detected. A kind of pre-established harmony to the universe. One disturbing example involves a chain of massive early galaxies that Webb discovered stretching across what astronomers are calling the impossible filament. This structure spans over 300 million light-years and contains dozens of fully formed galaxies that all appear to have begun their star formation at exactly the same cosmic epoch. The problem? At the time these galaxies started forming, light signals could only have traveled about 100 million light-years between them. How did galaxies separated by 3 times the maximum possible communication distance somehow coordinate their birth? This is a fundamental challenge to the principle of cosmic locality. Webb has also been detecting what researchers are calling causal loops in the early universe. These are cosmic structures that appear to be influencing their own formation through backwards temporal causality. The mathematics describing these loops are breaking every model of temporal physics we have. They suggest that effect might precede cause in certain cosmic situations, and that the future might reach backwards to influence the past in ways that create self-consistent but paradoxical evolutionary pathways. Next, the evidence for impossible cosmic recycling. Webb is observing galaxies in the early universe that appear to be made from matter that has already been through multiple cycles of stellar evolution, death, and rebirth. When Webb analyzes the light from these ancient galaxies, it's finding complex patterns of heavy elements, iron, nickel, cobalt, that tell a story of repeated stellar generations. The ratios and distributions of these elements suggest they've been recycled through stellar processes, not once, not twice, but potentially dozens of times. The problem is, each full cycle of stellar birth, evolution, and death should take hundreds of millions of years. For matter to go through multiple generations of this cosmic recycling, you'd need billions of years of cosmic history. But Webb is seeing these signatures in galaxies that formed when the universe itself was younger than the time it should take for even a single generation of stars to complete their life cycle. It's like finding a vintage, centuries-aged wine in a cellar that was built yesterday. This implies an astonishingly efficient and rapid process of chemical enrichment that our models simply don't permit. It forces us to ask, what if the timescale for stellar evolution itself is drastically wrong? The implications of what Webb has discovered go far beyond just challenging our understanding of physics. The telescope has been detecting what can only be described as cosmic artifacts scattered throughout the early universe. These are structures that appear to be artificially constructed on scales that dwarf anything we could ever imagine building ourselves. One particularly disturbing example involves a massive ring-shaped structure that Webb discovered in a region where the universe was only 800 million years old. This cosmic ring spans over 1.3 billion light-years in diameter and appears to be composed of galaxies arranged in a near-perfect geometric pattern. The precision of the arrangement is so exact that the probability of it forming naturally is essentially zero. Furthermore, the galaxies within this structure aren't just randomly positioned. They're organized according to mathematical relationships that follow complex number sequences and geometric progressions. Webb has found dozens of these artificial cosmic structures scattered throughout the early universe. They all share the same characteristics: perfect geometric arrangements of galaxies, mathematical precision in their construction, and evidence of ongoing functionality that suggests they're still operating billions of years after their construction. The scale of engineering required to construct these artifacts is absolutely mind-boggling. We're talking about civilizations or intelligences capable of moving billions of galaxies into precise positions across regions of space that span significant fractions of the observable universe. The energy requirements alone would exceed the total output of thousands of galaxy clusters. This suggests a level of cosmic architecture we simply cannot comprehend, pushing us into a realm of truly speculative science. Webb has also been detecting something that's forcing physicists to reconsider the most fundamental assumptions about the nature of existence itself. The telescope is observing regions of space where the normal laws of physics appear to break down completely. These are cosmic zones, where matter behaves according to principles we've never encountered, where energy flows in patterns that violate conservation laws, and where information can apparently be created from nothing. One particularly disturbing example involves a region that Webb has designated as Paradox Zone Alpha. This area of space, roughly the size of our solar system, appears to contain matter that exists in impossible states. The spectroscopic analysis reveals chemical signatures that shouldn't exist according to our understanding of atomic physics. Elements with impossible electron configurations, molecules that violate the principles of quantum chemistry, and compound structures that seem to exist in multiple dimensions simultaneously. What's particularly unsettling is that these paradox zones don't appear to be unstable anomalies that quickly collapse back to normal physics. They seem to be stable, persistent regions where reality operates according to completely different rules. Some of them show evidence of having existed for billions of years, maintaining their impossible physics, while the rest of the universe evolved according to the familiar laws we understand. These discoveries are forcing scientists to confront the possibility that our universe might contain multiple physics systems operating simultaneously. Maybe the laws of nature aren't universal constants, but rather local regulations that can vary from region to region. This possibility completely shatters the fundamental assumption of cosmic uniformity. The final, terrifying implication of all these findings comes from the cumulative data, suggesting a highly orchestrated, impossibly mature, and even artificially structured early universe. Webb has detected what researchers are calling destiny anchors, scattered throughout our observable universe. These are cosmic structures that appear to be locked into specific evolutionary pathways that will inevitably lead to particular future states. The anchors seem to be maintained by information flowing from future state dimensional layers that ensure cosmic evolution stays on predetermined trajectories. We might be living in a universe where free will and random evolution are illusions, where every cosmic event, from stellar formation to the emergence of consciousness, is being guided toward predetermined outcomes by intelligent systems that already exist in our multidimensional future. Our entire cosmic history might be nothing more than the unfolding of a predetermined plan. The James Webb Space Telescope isn't just revealing a universe that's stranger than we imagined. It's showing us evidence that we might be living in a reality that's just one layer in an infinite multidimensional consciousness system, where intelligence, awareness, and cosmic evolution operate according to principles so advanced and sophisticated that our current understanding represents only the tiniest glimpse of what's actually possible. In this mysterious, magnificent, impossibly complex cosmos we're privileged to call home, the universe is calling to us, teaching us, showing us wonders beyond imagination, and somehow, beautifully, impossibly, we get to be here to witness it all. If this changed how you see the limits of cosmic time, watch this next on the strangest molecule signatures beyond Neptune to keep the story going.